Hello geometry, good morning. We're going to look at our first transformation. So section 5.1, we're going to first focus on translations. I have a learning target for you. I can translate figures in the plane, and you'll be successful when you can describe translations using translation vectors. We'll see what that looks like. And also make sure to classify translations as rigid motions. Take a second, pause if you need to. This right here is just review from what we talked about on Monday/Tuesday last week when I saw you. So again, transformation is just a function that's going to change a figure or graph. It's going to change the position, shape, or size. The pre-image is something that we call the original figure. One thing I didn't mention last week was that if you're translating a point P, there's your original point. After translating it, or transforming it, excuse me, and getting the image, point P is now called P prime. So as soon as you add that little asterisk or quotation mark at the top there, that's now called P prime, which represents the image or the transformed figure. Again, we were talking about rigid motions, which are translation, rotation, reflection, and those are rigid because they preserve distance, angle measure, collinearity, and betweenness. This should all be in your notes. Just a quick review. Here's our new section. So translation. Again, we talked about this as just moving something. So the full definition of this is that it maps every point of a figure or graph the same distance in the same direction. Key words there are translation, you've got a distance, and you have a direction to go. For vector, we're going to talk about using vector components here. A vector is just a quantity that has both direction, again, keyword direction, and magnitude, which is basically another way to say distance, all right? So we're going to use vectors when we translate our points. Let's take a look at a quick example. Pause if you need to. All right, so look at these two triangles. Over here, I have the pre-image triangle ABC, and in the red on the right-hand side is the image after you've translated the triangle, right? A prime, B prime, and C prime. You see those little asterisks or quotation marks, excuse me. The vector below is labeled V. I'm just going to call it V for vector. It has a magnitude. It has a length, right? And what we're doing is we're taking point C, I'll put that right here in green, point C, and we're going to move it over to C prime using that vector length. We can see that it's about the same length as our vector, and it's going in the same direction. We also see that arrow on the vector, which indicates direction. So our vector V is being used to translate our triangle ABC. It has a distance, the vector length. It has a direction, the direction of which we're translating this thing. All right, and basically what we're going to do here is I'm going to add some notation to help us describe this. So I could say translation for T, this is called our vector notation. So we're going to translate, let's say we translate point B, and I'm going to put a subscript here. We're translating using vector B, and we like to draw our vectors kind of like when we did lines and rays. We put our vector name, and then above it we just kind of draw like a half arrow and a line. So this means a translation using vector V, a translation of point B. After applying that translation, you get B prime. All right, we won't use that too much, but nice to think about, hey, maybe I'll use that as an extra credit question. You never know. All right. Component form of a vector. Again, we can use this to describe translations on the coordinate plane. So let's say that we want to go from point S. Let's say that S is our pre-image, and we're trying to get it over here to T. So on the coordinate plane, we know that we are traveling 4 units in the positive direction on our x-axis. We're going 4 units to the right, and we're going down 3 units. We see that -3 there. So if we want to describe how to get from point S to T using a translation, what we're going to do is we're going to add these little angle brackets, and we're going to describe them just like points. So if this is X and Y, well, what's happening to our X? We're going to the right 4 units. So I'm just going to put a positive 4. What's happening to our Y? Well, we're going down 3 units. So down indicates going a negative direction. So I'm just going to put a negative 3. So that's how we can describe our translations with points using a component form of a vector. All right. You can use component form of vectors. Sometimes I also like to use coordinate rules because they just make sense. So let's take a look at this. You may want to get a little sketch of this down, maybe not word for word, but it might be a good idea. So if we want to do a translation to the right, again, that's going to be making a change on our X value. So take a look over here. All of the points that are labeled X, Y, that's thought of as our pre-image. After the translation, well, if we're moving A units to the right, maybe that's 5 units, maybe that's 10 units to the right, we're just going to take 10 units and add it to our X coordinate. And you see that right here. So after the translation, our original pre-image X, Y now becomes X plus A, Y. So we see that change happening to our X coordinate. It's a positive A because we're moving in the right or in the positive direction of our X axis. What if we wanted to move to the left? Well, then we're just going to minus A units. Again, maybe we're moving 3 units to right? Then we could describe our coordinate rule as X minus 3, Y. Same kind of deal here with moving up or down, so I'll highlight those. If we're moving B units up or B units down, well, now we're looking at making a change on our Y coordinate. So you're just going to add B to your Y coordinate or minus B to your Y coordinate, whichever one is appropriate for your translation. Let's look at an example of all these, all right? So I've got a coordinate plane here. Let's say we have a point at 1, 2. And let's say that I have a translation. I'm going to define this translation to be, it's going to take any point, X, Y, and let's say that I want to move it down 2 units. So if I'm moving it down, well, that means I'm making a change on my Y coordinate, and I'm moving it down 2 units, so I need to subtract. So this now becomes X, Y minus 2. Again, that minus 2 that's being added onto the end there represents moving down 2 units. So if I'm taking my original point, 1, 2, all I need to do to describe that translation down 2 units is just, well, my X stays the same. My Y coordinate, which is 2, I'm going to subtract 2 from it. It's pretty simple. And now my new image point is going to be 1, 0. So if I graph that, and I'll graph that in blue here, there's 1, 0. Yes, indeed, I took this thing down 2 units. Pause if you need to. You may want to get a sketch of this. We'll see more of this in review when you come to class. I've got 2 last more examples. All right, draw the pre-image and image of a polygon with these points. Those are our pre-image points. I already have them graphed and I put them in the table. And we're going to translate them using the vector for -2. So if we had to write this vector component for -2 as a coordinate rule, let me make that a angled bracket, sorry. If I wanted to write that as a coordinate rule, I could just as easily say, well, I'm taking a point, which is in the general form xy, it's got 2 coordinate points. So xy now becomes, well, What's happening to my x according to my vector form there? It's a positive 4, so I am adding 4 to my x coordinate. So that becomes x plus 4 in a coordinate rule. And my y, well, I'm just minusing 2 there. Again, just pulling that information right from the vector form. So I'm going to say y minus 2, and there is my coordinate rule all put together. So whichever you prefer, the vector form or the coordinate rule, is just as easy to just add 4 to your x's, minus 2 to your y's. So if I wanted to find a prime, well, the pre-image is at 0, 6, so make this a little smaller. So that means that a prime is going to be at 4, 4. Again, I got from 0, I added 4 to get 4. From 6, I minus 2 to get 4. Then I can plot a prime, which is, oh, it's right on top of another point. I'll plot it in pink right there. And again, we can see that if this was point A, well, it went down 2 units and then to the right 4 units, and I obtained a prime. For time's sake, I'm just going to keep it there. We'll do some more of this in class. One last one. What if you're not even given a picture? You don't even have a coordinate plane, and we want to be able to find a coordinate rule or vector form that would describe a translation. Let's look at what's happening to our coordinate points. So to the left-hand side, you have your pre-image coordinates in the form x, y. My image coordinates, again, these are the points after the transformation has happened. So how am I going to get, for example, from point A to a prime? Let's look at what's happening to our x and our y values. So I'm going to make this a little smaller again. To get from -4 to -6, what's happening? You're just minusing 2. So I'm going to write this as a vector form first, and then we'll translate it into a coordinate rule. What's happening to my x's? I'm just minusing 2. What's happening to my y's now? To get from 4 to 9, this is pretty easy. You're just adding 5. So -2, 5 would be a vector, component form of your vector that would describe this translation. Does it work for everything else? Let's go check point B and B prime. Point B has an x-coordinate of -1, so -1 minus 2 is still -3. If I have my y-coordinate on B is 2, well, add 2 to 5, you get 7 as well. So that checks out. You can check it for C and C prime and D prime. Once more, I want to translate this vector form into a coordinate rule. So, and we can see that getting started here in the table right now. If you're taking a point, x, y, well, its image, its point is going to be x minus 2. Again, that's all we did was take our x coordinate minus 2 from it. And then we took our y and we added 5. So there is your vector form and your coordinate rule. I'll probably use this one the most, but it's whatever you prefer. Hey, meet me in Blackman 107. Hit pause if you need to, and I will see you soon to check off some notes.